Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Let me introduce myself. My name is Shinta Indah. I'm from Department of Environmental Engineering, Faculty of Engineering, Universitas Andalas. Today, I would like to present my research. The title is Nitrate Adsorption onto the physically and chemically modified pumice. Contamination of nitrate in ground and surface water has become a serious environmental problem because high nitrate concentration in drinking water can cause health problems such as cancer due to the formation of nitrosamine. Therefore, World Health Organization said the maximum acceptable contaminant level of nitrate for drinking water is about 50 mg per liter. To remove nitrate from water and wastewater, adsorption is an effective technique because of its economical, easy design and operation, as well as low cost. For nitrate removal, different adsorbents have been studied, such as geomaterial like collinate and pumice. However, some of geomaterial has lower adsorption capacity. Therefore, various methods have been proposed to improve their adsorption capacity, like physical treatment by heating process and also chemical treatment by using chemicals, include acid, bases, mineral, and deoxidizing agent. So, let's talk about pumice. Pumice is one of geomaterial that has porous structure, large surface area, skeleton structure, low weight, and usually has been used for structural application. But now, pumice also can apply as absorbent for pollutant removal from water and wastewater. The objective of the present study is to evaluate the absorption capacity of physically and chemically modified pumice on nitrate removal. Now I want to explain about the material and method. The first one about the preparation of absorbent. Pumice stone was collected at the riverside of Sungai Pasak, West Sumatra, Indonesia, as byproduct of the processed sand mining in that area. Pumice was washed with distilled water several times and dried out at room temperature, and then crushed and sieved in order to find the desired particle fraction. And then we conducted the modification of pumice. For physical modification, pumice was heated at temperature of 300 degrees Celsius, 450 degrees Celsius, and 600 degrees Celsius for 3 hours by using this furnace. For chemical modification, pumice was soaked and stirred in 3 kinds of acid solution. They are chloride acid, and sulfuric acid and nitric acid at concentration of 1 molar for 4 hours, and then wash using distilled water and dry at 130 degrees Celsius for 3 hours. After that, we conducted batch adsorption experiment at room temperature with the optimum condition. For pH, less than 63 micrometer of adsorbent diameter, 0.3 gram per liter for adsorbent dose, and 30 minutes for contact time. The concentration of nitrate in the supernatant was measured by using spectrophotometer UV phase. This is the equation that we use to calculate the removal efficiency and the nitrate uptake on the natural and modified pumice. Now I want to explain about result and discussion. This figure shows removal efficiencies and nitrate uptake of natural and modified pumice by physical treatment. An increase in the removal efficiency and nitrate uptake by using modified pumice by heating at 300 and 450 degrees Celsius was observed. However, the lowest removal efficiency and nitrate uptake were found at modified heating Pumice at 600 degrees Celsius. These figures show the same image of natural pumice and modified pumice by heat treatment at 300 degrees Celsius, 450 degrees Celsius, and 600 degrees Celsius. The natural pumice has relatively large number of pores, but the pores are covered by other compounds. And modified pumice heated at 300 degrees Celsius and 450 degrees Celsius are revealed to have more number of open pores and increased pore volume and surface area of the pumice. However, heating treatment at 600 degrees Celsius seems to cause fewer pores due to damage in the structure of the absorbent pores caused by overheating temperature. This is the result of chemical treatment of modification. These figures show an increase in removal efficiency and nitrate uptake by using the chemically modified pumice. The highest was found by soaking in sulfuric acid, continued by chloric acid and nitric acid. It indicated the different interaction among the acid solution and the pumice. These are same image of natural pumice and modified pumice by acid solution. The pores of natural pumice were largely in number, but were covered by other compounds or impurities. But the surface of modified pumice by acid solution appear to be cleaner, uncovered by impurities, rust, more porosity, and deep cavities, which can be proper site for absorption of pollutant. And modified pumice with sulfuric acid has a more porosity and heterogeneous than the other sample. This is a comparison of removal efficiencies and nitrate uptake of natural pumice and modified pumice by physical and chemical treatment. From this table, we can see that removal efficiency and nitrate uptake by using modified pumice are higher than by using natural pumice. It was revealed that the modification of pumice physically and chemically increased the removal efficiency of nitrate uptake. Finally, I want to explain you about the conclusion. The results show that physical and chemical modification proved to increase the removal efficiency and nitrate uptake. For physical modification, performance of the heat treatment at 300 degrees Celsius was the best temperature for enhancing the removal efficiency and nitrate uptake. For chemical modification, the highest removal efficiency and nitrate uptake were achieved by using the modified pumice by soaking in sulfuric acid. The result of scanning electron microscopy analysis demonstrated that physical and chemical treatment modified the pore structure of the natural pumice that could change the surface area and chemical functional group on the surface of the pumice. And then it's the end of my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.